What's up, everybody? Welcome back to another live stream from Scalar Learning. And today we are back to SAT Math from Khan Academy, straight from the source, from the nonprofit organization that is partnered with the College Board. So you know their content is pretty awesome. All right. So let's jump into the, center, spread, and shape of distributions problems. Here we go. All right, question number 1. And as always, if you're new to these live streams, I am seeing these problems for the first time and doing them fresh so you can see the thinking process up front and close and personal, and it's fully applicable to you on the real thing. Here we go. Judah, a marketing consultant, tracked how many times... Here, let me take a picture of this graph. How about? Let's do it like this. This way we can see the graph while we read the question. Oh, come on, whiteboard Fox. Yeah, let's try this again. Maybe this will be better. Don't glitch on me, my friend. No, it doesn't like it. Hold on, let me try one more time. Let's do a bigger screenshot, maybe. Let's try this one. Don't give me an error. All right, so let's do, wait, the other one. The drawing is not as smooth on this one. That's what always trips me up, so it's all good. Okay. We don't need to write much, I think. Judah, a marketing consultant, tracked how many times his customers asked a question during his sales call over a 1-month period. Okay. Based on the results shown, what was the median number of questions asked? Okay. So check this out. We've got, each one of these represents a customer, essentially, right? So we're saying like one customer was asked one question, four customers were asked 2 questions, so on and so forth. All right. We need to figure out, first of all, if we want the median, we need to figure out how many customers or how many of these dots there are. And then find, the median is middle value, right? So I'm going to count it up. So you got 1, 4, 4, 6, 5, 4, and 6. So 5, 9, 15. This is a no calculated question, right? So 15, 20, 30. Okay. So there's 30 total. Now, this is very interesting. The median's not at 15. The median for an even number is actually going to be in between 2 numbers. It's going to be in between 15 and 16. It's going to be actually the average of whatever 15 and 16 are. This is because we're talking about 1 through 30. So if I wrote it all out as 1 through 30, in fact, the middle value wouldn't be at 15. That would almost be the middle value. There is no an actual middle value. So we got to count up to the 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, so you see my 15th guy is here. I should have just added these up. This is 15. And then my 16th value is here. So it's not, and so the median is in between 4 and 5. So we take the average of 4 and 5, which is 4.5. That's how whenever there's a median of an even number, that's what we do. We take the 2 middle values and take the average of them. And it is 4.5. All right, next question. Let's do the same dealio. Let's take a nice screenshot. Hold on. Okay. Boom. A class catapults to launch 2 kinds of gummy candies. The dot plots at left record the distances the gummies traveled. Wait, what? Catapult. Oh, this is so hilarious. I read that, but I didn't process it. Which statement best compares the standard deviations and the means? Okay. Standard deviation just represents the spread of the data. So if it's got a smaller standard deviation, it's going to be more lumped together. Like this one probably has this has a smaller standard deviation for sure, because look, it's only 60 is the range, and you see like things are heavily clumped here and stuff, whereas this one, the entire range is almost 90. So this is going to have a smaller standard deviation. And then the means, well, whatever. Let's start there. The worm gummy distances have greater. Okay, yes, it has a greater standard deviation. So right off the bat, C and D are out. Because I already said the fish gummies have the smaller standard deviation. So the worm gummies have the greater standard deviation. It's either A or B. That's pretty good. Now we got to compare the means. And then the mean is probably going to be higher for, oh God, like, because I don't want to obviously calculate, that's craziness. I'm guessing the mean is higher for the worm gummies. I'm guessing they're higher for both. Yeah, I think it's both. But let's look at this a little bit more carefully now. How many did they throw? Did they give me more details? So if I were taking this thing for real, I'd probably just stop here and go for A, because definitely that's what it looks like. And I don't think they actually want you to calculate this, but it definitely looks like that. If I did a quick thing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then 14, and then that's 9, 12, 6, 26 or something. It's like about 40, and it looks like, I'm guessing my mean is going to be around here. Or it's going to be like around here, around 80. That's just like an estimate. You know, I have a bunch here. I have like a huge chunk concentrated here. I bet if I added up all these values, it's going to be somewhere around here, maybe around 85. Okay, in this case, we're more heavily lumped on this side, okay? But look how much I have to the right of 85. I have a lot, and I have some big values over here. So I'm pretty sure, even at best, if this mean is 85, I'm betting my worm has I'm betting my worm has like a mean somewhere around 105 or something. So the worm has a bigger standard deviation and mean, so I'm pretty confident. Good. It is correct. Next. Whoa, lots of drawings. Hold on, let me maximize this and take a big screenshot. This is like craziness. We'll put both of these up on the whiteboard. It'll be easier to see. Okay. That is humongous. Let's do it like this. All right. Now, the histograms to the left show the test results of 2 different 11th grade history classes on the same exam, okay? These are the ranges of the scores. Which statement best compares the standard deviations of the 2 sets? All right. Let's see. So again, this is the spread of the data. In this one, we have a ton of people in this range. This is more spread out, okay? Because here it's like it's more lumped together in this range. And then we got a couple fringes, right? Versus this one, it's all spread out, kind of like the data's more spread out. So I'm saying B has a larger standard deviation. Done. Standard deviation of the scores from class B is greater. They're not equal. I'd say B is greater. Boom. I don't even know what it says, but yeah, that's it. Look, see, because it's more spread out distribution relative to the mean. That's basically it. Okay, next, a candidate in a local election analyzed the voter data for 7 of the towns where she was on the ballot. Is there a graphic? Wait. If the median number, hold on, let me clear this. If the median number of votes that she received from the 7 towns was 421, let's write this out. 1, 2, 3, 5, 6, 7. So here's 421 right in the center, right? And then which statement must be true? The total number of votes she received in all. No, that doesn't have to be true. The median could mean nothing. Like she could have gotten 10,000 in this last one. So A is definitely, it doesn't have to be true. And always beware of that must be, right? The total number of votes the candidate received in each of the towns was 60. That obviously makes no sense because I don't even know where they got 60 from. That's really weird. No. The candidate received at least 421 votes. Yeah, this is true. Because these other ones, so the median again is the middle value, and then these have to be higher, and these have to be less if it's the median. So C is actually true. Let's just look at D anyways. The candidate received exactly 421. No, we don't know if it's 2. These could be, well, actually, these don't have to be less. These could all be the same, or like these two could be the same. You know, we don't know. So it could be 2. It could be, she could have received 421 and 3. She could receive 421 in all of them, but we don't know. So it's C. All right, last but not least, we've got question 5, and we don't need to take a screenshot. In San Francisco, the number of employees in each occupation was recorded and rounded to the nearest 5,000, right? 0, 5,000, 10,000, 15,000, whatever. The results are displayed in the plot above. If each occupation is split into 2 separate occupations of equal number of employees, which of the following occurs? Wait, what? If each occupation is split into 2 separate... Oh, I'm trying to wrap my head around that, what that means. How can you split an occupation? The number of employees split into 2 separate occupations. All right, I guess there's just whatever theoretically. So then it would be... Let me understand this graph. So it's saying like this isn't a wholly separate occupation. This is like lawyer, doctor, engineer, I guess. This is, you know, each one of these dots represents a single occupation, and then these two have 20,000 each. These have 30,000. So I think something like that. So they're saying it's split into 2 separate occupations. So this would still be 0. These would be like 25, 25, 25, you know, 8 in 2,500. Okay, I think I understand it, but let's see. Only the mean number of employees decreases. Hold on, I gotta think about that for a second. So instead of like 4, let's just take this for example. Instead of like 5, 5, 5, 5, where it's 5 plus 5 plus 5 plus 5 divided by 4, it would be 5. It would be like 2.5, 2.5. And it'd be 8 of them. 20 divided by 8. Yeah, and what would be 2.5? The mean would go down. So the mean would go down. Hold on. The mean and median would decrease. The range would also decrease. Because now this is no longer 100, this is 50. Everything would decrease. So the mean and median would decrease. So I'm saying A is out. The range would definitely decrease. The standard deviation would... The standard deviation would also decrease, actually, because the data would be more compressed. Now it wouldn't be from 0 to 100. It'd be 0 to 50. And, like... This would be 35, 35. This would be 25, 25, 25, 25. This would be, you know what I'm saying? So everything would come down. I'd say the only, like, it's definitely either C or D, but I'm feeling like the standard deviation would also decrease as everything compresses. That's the only question mark. I want to see if this is correct. Yeah, it's correct. Yeah, because the general shape decreases because the fact that it gets narrower, it goes whoosh, cuts down. All right, good. So that made sense. But that one did trip me up for a second, so I just wanted to make sure. The mean, median decreases. Oh, and they would still round to the nearest 5. See, that doesn't, they didn't explain that actually. I assume that you're no longer rounding to the nearest 5. And I mean, that's a weird question. Sometimes these questions are not, I mean, I've never seen anything like that, even close on it. I mean, similar to asking about standard deviation and mean and so on, but I've never seen a question like that on any of the real SATs I've taken or seen or processed. So I'm not sure that's so representative. I wouldn't go stress too much about a question like that. But there you go. I think the other four are decently representative. All right. Thank you guys so much for joining. And I hope that was helpful. If you like this video, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. We got all your test prep and good content here on the reg. And I'm getting my SAT score this Friday, so make sure to look out for the live stream for that, as I will keep you guys posted on my score. Hopefully I did well. All right, that is it. Have a great rest of your day, and I'll see you all next time. Take it easy.